In this video, we prove by the method of induction that 3 plus 3 square plus 3 cube and so on up to 3 to the power n equal to 3 by 2 times 3 to the power n minus 1 for n equal to 1 to 3 and so on. So as we said that we want to prove it by induction, then we need three things. One statement, and then a base case should be true, and we should get some kind of cycle. So we got the statement Pn to be 3 plus 3 square plus 3 cube plus so on up to 3 to the power n equal to 3 by 2 times 3 to the power n minus 1. What do you think is the base case? We just write n equal to 1. So 3 equal to 3 by 2 times 3 to the power 1 minus 1. That is 3 equal to 3. Which is true. The base. In other words, Pn is true for n equal to 1s. Now we need to show that Pk plus 1 is true whenever Pk is true. Next, we want to obtain a cycle that says that Pk plus 1 is true whenever Pk is true. So we assume Pn is true for some n equal to k. That is 3 plus 3 square plus 3 cube and so on up to 3 to the power k is equal to 3 by 2 times 3 to the power k minus 1. So this is true. Then, now we need to show that it is true for n equal to k plus 1. So 3 plus 3 square plus 3 cube plus dot 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 plus 3 to the power k plus 3 to the power k plus 1. By our induction assumption, this sum is exactly equal to 3 by 2 times 3 to the power k minus 1. Rest of the expression we can copy as it is. So 3 to the power k plus 1. Now let's simplify this expression. We take the LCM as 2, 3 times 3 to the power k is 3 to the power k plus 1 minus 3 plus 3 to the power k plus 1. Now we can take 3 common and say that, we should simplify a bit. One number of 3 to the power k plus 1 and 2 number of 3 to the power k plus 1 gives you 3 number of 3 to the power k plus 1 minus 3 by 2 we copy as it is. That's equal to, now we take 3 common and write 3 to the power k plus 1 minus 1 by 2. Now we see that pk plus 1 is true whenever pk is true. That is, if I write n equal to k plus 1, if I write n equal to k plus 1, then we get 3 by 2, 3 to the power k plus 1 minus 1. Did we get? Yes, 3 by 2, 3 to the power k plus 1 minus 1. So we can say that pk plus 1 is true whenever pk is true. But we have already shown that p1 is true. From there we can say that p2 is true. And even we repeat this cycle to say that if p2 is true, then p3 is true. Again we repeat this cycle to say that if p3 is true, then p4 is true. So by principle of mathematical induction, 3 plus 3 square plus 3 cube plus dot 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 and so on 3 to the power n equal to 3 by 2 times 3 to the power n minus 1 for n equal to 1, 2, 3 and so on.